you for all you guys joining our session today. And I think this is really my honor to represent MicroStrategy to do a session in the Krakow code Europe. And I am a product owner in the MicroStrategy, and my name is Paul. So today I'm going to talk about the enterprise analytics applications using the native Hadoop Gateway. And I will give you guys an overview of our product, which the Hadoop Gateway we built for the MicroStrategy business intelligence application. And I will be invite my colleague Huang Ying to give you all more details about the technical stuff and some highlights of our implementation. So before I jump to our presentation, let me introduce our company, MicroStrategy, a little bit. So MicroStrategy was founded in 1989, and MicroStrategy is a provider of business intelligence, mobile softwares, and cloud-based services. Over the last 25 to 27 years, we helped our customers to transform their data into the intelligence and help them to discover the new opportunities in daily business by our softwares and to drive the results in their business. So, so let's talk about something about big data. So I think it's a good question to ask all you guys here. So how is the big data impact our daily life and our daily business? So I think in order to answer this question, it's better to take the steps back to our last couple of years. So more and more data is trying to be analyzed right now than at any point in history. So most of our customers in our industries, enterprises, they are facing this couple of challenges here. So actually, more and more data is arriving faster than current data warehousing platforms are able to absorb and analyze it. And also, the cost to scale the traditional data warehousing platforms is pretty high. And eventually, it becomes prohibitive. So a lot of our customers, they are trying to migrate their current data warehousing platforms to the distributed file system. And also, they are using the Hadoop system to store the large amount of data, right? So it's, I think it's mandatory for a business intelligence application to connect to the big data source. And also, if you ask any BI company, so what is the most frequently used connections to the Hadoop system, they will all answer you ODBC or JDBC drivers. Okay, that's fine. MicroStrategy also provides this kind of drivers as well. But actually, there are a lot of limitations on top of the JDBC and ODBC drivers. Okay, so first of all, all the data in the Hadoop system need to be organized as a Hive tables or some logical tables so that all the existing applications or downstream applications, they can consume the data from the Hadoop system, because a lot of data on the Hadoop system, they're unstructured data like social media data, like some stream data. Okay, and secondly, actually, so the JDBC and ODBC, there could be a lot of bottlenecks when transferring a large amount of data from the Hadoop system to the MicroStrategy intelligence server. And so what's our solution here? Okay, so our solution is we built our native connector, Hadoop Gateway, and based on top of the Spark technology. I think Spark technology is very famous and popular. The big data data processing engine, currently a lot of people are using the Spark. So we created a connector, the native connector, to allow the user to browse, to directly access the HDFS. Okay, and also we tried to make the connector more with more with higher performance, actually. We try to make it as a data transmission in parallel in order to improve our data transmission performance. Okay, so here we have some major capabilities of our Hadoop Gateway. So the first one actually is my favorite of the Hadoop Gateway. So we allow the business user to bypass the ODBC and the JDBC driver. So the user can access the HDFS, they can browse, and they can drag the folder, they can pick up the file from the Hadoop system directly. And then you can do a lot of data wrangling. Data wrangling here means that the business user, they can do a lot of data cleaning and data transformation by themselves. It doesn't require any support or anything from your IT engineers. Okay, and also in last couple of releases, we tried to add the aggregations and filtering, which help the business user to filter out some interesting data and to add some customized aggregations functions on top of your data. And finally, we will send back the data to the MicroStrategy analytics system in parallel. So it's pretty high performance. And also we support different kind of data access mode. I will talk about this later. And also for security reasons, we integrated with Kerberos authentication. Okay, so here we have a couple of slides and just a few screenshots to describe the major functionality and also okay, so during this data discovery stage, you will see that we allow the user to browse the Hadoop file system directly. So you will see here all the folders, files are listed in the left side. So user can pick up the table, pick up the file. You don't need to pick up a table or pick up the database like ODBC or JDBC driver. And also, we support the Hadoop name node high availability, which is pretty important and the requirement from our customer. And also, our Hadoop Gateway is able to support different kind of formats. So normally, it's text file, JSON file, and also some typical big data file formats like Parquet, AVRO files, and org files. Okay, so right after you just pick up the files or you just try to preview the data, you will see that we have the data wrangling function here. So actually, you can do a lot of data wrangling to clean up your data. You can even import the predefined script to do the data transformation. So our data wrangling integrated with the Google OpenRefine. So you can write some data wrangling or OpenRefine script by yourself and save it and just import it here to do the data cleaning. And this is the aggregation and filterings. So here you can see that we have multiple different functions for the user to choose to set up to fetch the data or filter out different kind of data. And also, this is the basic categories functions we support in the MicroStrategy. We integrated with the Hadoop Gateway. And also, the most important thing here, all the aggregations and the filtering, we will translate to Spark SQL. And we'll be pushing down to the data source, to the Hadoop Gateway. Because the Spark provides a very high performance data processing engine, so we will take the advantage of the Spark performance here. All right, so here I just want to talk about a little data access mode. So there are two different kind of data access modes here, the green line and the red line. Okay, so the red line is the pretty common scenario in MicroStrategy. So as soon as the intelligence server sends a request to Hadoop Gateway, then we will fetch the data from the Hadoop system and save the data back to the intelligence server as intelligent cube. You can just imagine that this is a very high performance data cube to support our dashboard and our visualizations at the end. Okay. And also the green line. Green line is the direct data access because we got a lot of requirements from the customer. They want to do some analysis on top of the real data, right? So we also support they create the request from the intelligence server to the Hadoop Gateway, and the Hadoop Gateway will return the data immediately back to intelligence server and show any data change on your dashboard and the visualization. Okay, so Depends on the Spark. We also provide different kind of the deployment mode. So there are 3 different modes, deployment modes you can choose. The first one is Yarn. So Yarn is quite a common usage at the customer side, and most customers are interested in it. And so Hadoop Gateway just send the request to the Yarn service and request a resource from the Yarn container, and all the jobs and tasks will be executed in the Yarn container. And also, during the Yarn deployment mode, we can integrate with the MIT and AD Kerberos authentication. So for large kind of enterprises, they require pretty high security compliance. So the Yarn deployment will be the first choice. Okay, so if the Yarn service is not enabled in your cluster, the second choice is standalone. So standalone actually is provided by the Spark engine. And the standalone mode, we will submit all the tasks and jobs to the Spark master. And the Spark master will coordinate all the resource and the tasks and execute your request in the cluster. So the final one is local mode. So for the local mode, actually, all the tasks and all the requests will be executed in your Hadoop Gateway machine only. So in local mode, it's some kind you just use the local mode for the troubleshooting and the application testing. Okay, so next I just wanted to explain the Hadoop Gateway in a 3 minutes short demo and to show all the capabilities in action. Okay, so in this scenario, actually, just imagine that you are a manager in Florida for a bookstore, and you only have the profit data. You have all the analytics here for the month level. Okay, and actually, you want to see what will be going on in the next couple of months, and you want to dig out something from the monthly data, but you also want to drill down the monthly data to the weekly, even daily. But actually, there are a lot of transactional data. They actually saved not in the relational databases. Actually, all this kind of data saved in the Hadoop system. Okay, because save the transactional data in the database, the cost is pretty high. But unfortunately, your cluster admin, John, is out of office. He is in break with the family, and you are not able to ask him to translate or to organize your data to a Hive table or a logical tables. So you cannot use the JDBC or ODBC drivers. So right now, they have different choice, Hadoop Gateway. Okay, so let's see how Hadoop Gateway works here. Okay, so you can see we want to try to see the weekly and daily data of the bookstore, and we can just click this, try to import data from the Hadoop Gateway. So here you can see that all the folders and the files are listed, right? So allow the business user to drag the file from this left side. And also for the security reason, they only able to browse the file. They cannot see anything inside the file. They cannot preview the file right now, right? And also, another amazing thing is if the folder contains all of the files with same structure, actually, you can drag the folder into the right side. And all these files will be combined as a single table, and you can manipulate, you can do a lot of things on a single table. So it's kind of, we call it auto partition, right? So let's just try to drag the folder into the right side and click the prepare data. Okay, yeah. So here you will see maybe the format, the data format is not what you want. And you want to do some transformation, you want to clean the data, you just click the wrangler button to initiate the data wrangling process. So here you will see all the columns will be displayed, and you can import just predefined script and to do the data transformation. Okay, then you click save and back to the preview page, and you can drop off a couple of columns, and you can switch the column between the attribute and the metric. This is the model in the MicroStrategy, and even you can change the column data type from integer or string to data type, something like that. So click the finish, then the cube will be published, and you can check on the process in the cluster admin page. This is the resource manager page. You can see all the tasks are executed, are running in the backend. So you can see all the progress here. So back to our page. So you will see that, a few seconds later, the cube will be published into our intelligence server. So you will see one more table here. Right? So you can add more columns and attributes and match to build your visualization, to build some light chart or maybe some different kind of grid to find what you want here. Okay. Yeah, so this is the very short demo to describe how Hadoop Gateway works for the MicroStrategy. And so here I needed to really want to mention that Hadoop Gateway has a very, very high performance data transmission because we transfer data in parallel. So this is a pretty high level architecture of the parallel data loading. So you can see that the driver actually is our Hadoop Gateway. And we submit the job to the cluster, and all the job will be distributed to the different work nodes. Right? And right after the work nodes finish their job, finish their data processing, all of the data will be transferred back to iServer in parallel. So for the traditional JDBC or ODBC drivers, you can probably kick off the job in parallel. But actually, finally, all the data will come back to your driver and send back to the intelligence server in single thread. So this is actually what I'm talking about, the bottleneck of the JDBC and ODBC driver. And this is some performance statistics which we did in-house with our testing clusters. You will see that the traditional ODBC and JDBC driver, the average data transfer speed is only about 20 megabytes per second. But along with the Hadoop Gateway, because we use the data transmission in parallel, so along with the scalability of the cluster and even larger the cube size, you will get at most 749 megabytes per second. Okay, so imagine that if you want to publish a 10 gigabytes cube to the MicroStrategy intelligence server. So for the ODBC driver, it could take 500 minutes. I think that's unacceptable for the current business. It's pretty long time, right? So the end user, the business user, they are unable to wait so long time. But with the Hadoop Gateway, you just take half an hour to publish the 10 gigabytes cube into the MicroStrategy server. And also, I want to just finish my part with some customer success stories here. So this is the example we did. We did the performance evaluation in one of the largest digital media company in the United States. So actually, the customer would like to publish 150 million rows, and also they even want to publish 500 million rows to from the Hadoop system to the MicroStrategy server. So you will see here the orange part is the time which being used in the intelligence server to publish the cube, to manipulate the cube, to create the data intelligent cube. But actually, the red bar in the bottom, it's the real time. It's the time for the data transfer from the Hadoop system to the MicroStrategy server. So you can see for the Hadoop Gateway, we just get maybe just half of time, even less than half of time to publish the cube compared to the Teradata. The Teradata using the ODBC and JDBC driver. Okay, so next the customer success story is we did in the last year with one of the largest retailer company in Europe. And in this story, we will see that the red bar also the time we transfer data from the Hadoop system back to the MicroStrategy intelligence server. And also you will see here the orange bar is the data wrangling time, which because we include some data wrangler operations during the cube publication. So for the JDBC and ODBC driver, for the Hive, they will use a lot of time for the data wrangler operations because all the data will come back, the raw data come back from the Hadoop system, and then we do the data wrangler operations in the MicroStrategy server. But here you will see just very tiny time, very little time to do the data wrangling. So why? Because all the data wrangling operations, we will push down it to our Hadoop gateway. Okay, so actually, everything that the user did in the data wrangler operations will be pushing down to the Spark side, and we use the distributed file system, distributed data processing engine to finish all the data wrangler operations. So the entire Cube publication time is pretty less compared to the Hive. This is the ODBC driver. Okay, so this is the high level of the Hadoop Gateway product. And hopefully, I already catch your attention here. And I will hand over my part to Huang Yi. She is our key member and key engineers who develop the Hadoop Gateway. So let's welcome Huang Yi.
Thank you. Everyone hear me? Hello, everyone. Here is the coder's time. And my name is Ying. I'm working for MicroStrategy for more than 8 years. And currently, I'm the principal design software engineer in the big data team. And I also have some experience in DevOps and Mesosphere for private cloud, something like that. OK, now I'm going to show you what MicroStrategy doing under the hood. I mean, for the Hadoop Gateway, how we design code, how we design the code implementation. Maybe show a piece of code for you. First, I want to define that for MicroStrategy, the whole product is not only for the Hadoop. It's basically a data-intensive system. And he's building all the data-intensive system from bottom to up. From bottom to up, what I mean is that from the data gathering, from we import source, and we use some data wrangler and to change the schema. Then we put into some derived metric and derived information into the cube. After that, we build a business inside of it. That's what we basically do for the MicroStrategies. But before that, for the data sourcing import part, we usually import like a database. But currently, because the data layer became more and more complicated, so we need to use some new tools. And I borrowed this slides from one of our customers. This is actually what their data layer look like. As you can see that there are many structured and unstructured data source, and they are putting everything into a data lake. After this, they are using Hive, some Hadoop-like system to extract the data and put it into some cube. After that, they build the dashboard. This is what they actually do. So for our system, for our Hadoop Gateway product, we actually simplified the inner part, the data lake part. And without using Hadoop, we are using Spark. And I think that's the best for the self-service data science, which Paul already mentioned, that they don't need to care about the data location and data format. They just need to run the business insight and the ad hoc data queries. And I think our product is with little configurations. That's a good part also. And next, I'm going to introduce why we choose Spark as our basic distributed calculation engines. You already probably know that Spark has very good programming models. As you can see that on the right side, it's the typical Hadoop word count samples. It's like one-page code. And on the left part is the Scala. It's the Spark one. You only need 2 or 3 lines, which is fantastic. This is not only benefit from our Scala programming. It's also benefit from the Spark's programming models. It had a very gentle learning curve, and also he translated the map-reduced typical programming model to transform an action, which is very easy to use. And I'm going to talk a little about the Hadoop performance bottleneck, because they have a lot of disk scan. A typical Hive sequence will translate into skip the first rows. We will translate to 13 scans of the data during you process the Hive sequence. That's as our statistic, which is the bottleneck, and will slow down the performance. We want to skip that. But for Spark, as we all know that it's famous for the efficient pipeline. If you're at one stage, which is before the shuffle, every map is translate one mapped RDD to another. And during this time, and there is a pipeline to in memory for all RDDs transform the data. But for Hadoop, it's all written to the all need disk scan to put everything into disk. That's slow. So Spark has best performance than Hadoop. Then for our enterprise, we have a good SQL engines that we have already have the SQL engine part. So Spark has good performance on and support on the SQL interface. I borrowed this chart from the Databricks company, and this is the inner module and inner workflow, how a SQL is translated to the query plan. After you load the data into the data frame, it will translate it into the logical plan, and the logical plan can be optimized. It can be optimized means that you can translate a SQL into some grammar tree, and you can lower down some filter and projector, which means you can reduce your data size as early as possible. After that, you can it will be translated into physical plan, and the physical plan will choose a cost model. What is cost model? For example, if you are doing a job, you are doing a join for 2 RDD, and one of them is the data size is fairly small. Spark will not do a regular RDD join. It will load the whole data set into the Spark and use a broadcast object to separate them to every executor, which will increase the performance a lot. So as all of this, we think we are very positive about this framework. And since Spark is keep growing, so we choose it as our basic calculation engine. So I'll skip this part. But after we release our product and collect some feedback of our customers, we still find some limitation about Spark. I think that's normal. First is the memory consuming. As we, according to our statistics, you need to allocate like 10 times than the data size in the memory to successfully launch the Spark application. And then there has some issues about backward compatibilities. We used to support like a Spark 1.6, and then we upgraded to 2.0. In that, we found there are some issues because Spark claims that they support backward compatibility, but it's only in Scala, not in Java. But in our applications, we are hybrid in Java in the upper layer, and the API part is basically in Scala. So there are some cost down in the Java. We use the Spark API, and after we upgraded to the 2.0 above, it cannot compile. So because Scala Spark supports the backward compatibility using a Scala language sugar like type lines, which is not supported in Java. So ultimately, we're doing a Java wrapper for a different Spark version to solve this problem. And for others, the troubleshooting, I think that's a common issue for all the distributed system. Okay, I'll skip the other part. This is the inner module designed for our browse and preview workflow, which is we receive every request from MicroStrategy server and send it to HDFS. As you can see, the data node and name node. We design a proxy like this in our as a module. Our Hadoop Gateway is because that the web HDFS provided is not perfect because they cannot support name node HA, which is enabled by default by our most customers, and then it not has good support on the security. If we implement the proxy by ourselves, we can take the Kerberos principles. This is the execution workflow of our Hadoop Gateway. The query is not only browse the folder on the HDFS, it also including the query, the Spark SQL and the data wrangler commands and some aggregations. In this workflow, you can see that After MicroStrategy, other module we call the MicroStrategy server to submit a request to our Hadoop Gateway, which is installed on the cluster. Hadoop Gateway will start a Spark application and ask YARM to allocate a resource for us. Mostly in our customers' cases, it will use dynamic allocations. And it will start an executor on some nodes, on some worker nodes, and each executor is like a JVM, and it will contain multi-thread pools inside, and start Spark tasks concurrently. And after the Spark job is finished, which means the HDFS job is also finished, it will transfer all the data set back directly to the MSTF server and bypass the Hadoop Gateway. We design like this not only because it will have the best performance, it's also because that we want the Hadoop Gateway only became the query engine and the job schedulers in the whole process, so it can has a high concurrency workload. If we send back to all the data to the Hadoop Gateway, which also contains a Spark driver, the memory consumption will be huge. Okay. Next slide, I'm going to mention how we design the inner module of the Hadoop Gateway. As you can see that for the left part, this gray box is like different requests from our other server modules. And then in the middle one is the Hadoop Gateway. Inside of it, we provide communication using RESTful API and provide a TCP native server for using protobuf protocols and to pass the query from servers, MSTR servers. Then we have query processor and data loader, data wrangler. And data wrangler, we support the interface the same as OpenRefine. So, which means if you pass in the OpenRefine script, it can be passed and run directly. Besides that, we also have some cache managers, which not only manage the runtime memory and also the Spark cache. Also about the Spark job scheduler, which is designed for the concurrency. And the last most important module is data transmitter. This part is not only required on the driver program, it's also need to send to be the worker node, because this part is executed on the worker node's executor inside of it. Besides this main module, we also have some other module which is also important for our workflow. First is the Spark cross-version support and the event-driven monitor and the virtual table management and the data format translators. On the corner of the slides, I list all the text stack we have used from the web layer to server layer and to data layer. If you're interested, you can read the slides. I'll skip this part. Then I'm going to talk about show you a little bit of code, how we implement the parallel transmitters on the executors. As you can see that, this is what Spark context provides. There's the interface here, the run job. After you get the RED as a result, you can pass in the process partition functions. In these functions, we can pass in some function object in Scala. And in this function, we put in the MSTR server's network identifier as closure. So the function object already knows where we should send the data set. And this is what the function object look like. It's really obvious that we are using a data center to send the data set result and the partition index to the server. MR request info is actually the MSTF server's network IP or port, something like that. That's how we implement the parallel transmitters. After that, I'm going to talk a little about our memory issues and designs. I think if everyone is familiar with Spark, this chart should be sound similar for you, because we know that Spark load every data into the pipeline, so the memory consumption should be large. Besides that, because the JVM's object has very heavy headers, so if you load like 10 megabytes data into the memory in Java, it will not be just 10 megabytes, it will be a lot more. And because Spark supports cache, and if you put some RDD into cache, it will first load in memory. And if your strategy for the cache is memory only, it will stay in memory forever. So this kind of using memory is kind of aggressively, so it has strongly dependencies on garbage collection by the JVM. And for example, if you want to find out what's the minimum memory settings for one executors, if you are loading the HDFS file and HDFS file block, the default size is 128 megabytes. You should notice that this is compressed. This is not the same memory we are using when you load into JVM. After you load into the memory, it's like 3 times larger. And if you want some kind of concurrency in one executors, which means you can start like 3 or 4 Spark tasks in one executors, you need to multiply the thread numbers. And according to the graph we show here, there's only 60% of the whole memory can be used to loading your data set. And if you have very complicated queries, maybe you need more. So ultimately, for the minimum of one executor, for the default block size of HDFS is like 2 gigabytes. In our practical test, is usually like you need to allocate like 4 or 6 gigabytes. Put everything into together. This is the graph for how Yarn launched the Spark applications. You can see that there are a lot more configurations you need to take it into account. Okay, after we allocated enough memory for our applications, we started looking into our code to see if there's something wrong in our code because the memory consumption is so large. First, we go through there are some transform function that some developers use to array and for each, something like this. Actually, it's not a very good programming habit because it will load the whole partition data into your task, Spark tasks, which is one thread. And so, but Spark provide a better programming model called RDD iterators. If you use this kind of programming models, ideally it will load only one iterator's data, but and that's how Spark load more data when you memory is not enough. So I need to speed up a little bit. And let me talk a little about the JVM tuning, because JVM tuning and GC tuning is usually the last thing we want to do for Java applications. But for Spark, it rely on the JVM GC heavily. So this is a thing we should do. And the goal of the GC tuning in Spark, we want to ensure that the long-lived RDD will go to the older generations, and the short-lived RDDs should stay in the young generation and be minor GC quickly. So first one, we set a JVM to compress the Java object header, and then we use some better serialized register, and then we increase the young generation size. Yeah. And this is our concurrency design of Hadoop Gateway. We have different layers of concurrency. And the first is we have a natty TCP servers that to handle the concurrency query from MicroStrategy's other modules. And then we have inner job pools and priority queues to make sure that every job is in the queue and submitted with some concurrency. And here comes the bottleneck is the Spark and Yarn resource manager, because this concurrency depends on the resource of your clusters. Okay. And here I need to mention some issues we find in the Spark framework inside, but I'm going to skip the part. And the last part is the installations that we skip our program into some different jars and push to some different machines because they should act differently. Someone in the driver, you should contain not only the driver code, but also the distribution code and the Java code. One thing I need to mention that the Spark code on all of these machines should be on same version and also on same Scala version. If you don't do that, you will meet some class conflict. Okay, I think that's all for my presentations.
Yeah, thank you. Thank you
Okay.
for Huang
Do
Yi.
you have any questions?
Yeah. So I think we have a question for everybody here, and we prepared a small gift for you guys. And so the question is, what is the key point how we can beat the other ODBC and the JDBC driver and improve the performance during the data loading? So anyone can answer the question, you can get the gift here.
It's a way we send data back, how we send it.
Yeah. No one?
We have a gift.
Everybody is hungry, right? So because I think we also mentioned this at my party, even Huang described a lot how we implement some kind of data loading to improve the performance to publish. Hey, yeah.
Gentlemen?
Sorry? Yes, you're right.
You're right.
Yeah, so we send data in parallel
Okay.
from the H work node to the MicroStrategy intelligence server. So that's the key point how we can to beat other JDBC and ODBC driver. And this could be the best choice for you to use the native Hadoop Gateway as you are connected to the Hadoop system. And so I think we are running out of time. So
Sorry.
thank you so much for everybody coming to our session.
One thing, we still have a workshop this afternoon you can play with this Hadoop Gateway product. It's really interesting.
Yeah.
Okay, welcome to join.
And our booth in the second floor, and welcome everyone come to our booth to get familiar with MicroStrategy. Our company is the leader in the BI domain, and we always stay at the frontier of the technology. So thank you. Thank you all.
Thank you.